Hey guys, it's your host, it's your host Subhra. So welcome back to your favorite channel, Subhra the Geek. So guys, today we have another video of our statistics series. So these are the series which I have planned along with my very good friend Debayan. These are the series which are catering to the industry and actually what the industry wants. If you want to search machine learning on internet, you will be finding a lots and lots of materials. But often a time when I studied, I always got confused to which to study and which not to study. So this series is which we have planned for you guys will help you to identify the certain parts and certain things which we are talking to study, and it will help you in the industry. So guys, if you face any problem during the course of your journey, do comment on our Discord server which is linked down below. Guys, if you like our video, please give a like and please share it with your friends. And if you want to support me, do support me by sharing and subscribing to my channel. It was great and wonderful staying with you guys. So I am your host Shubro, and along with me is
Debayan.
today we are gonna talk about linear models, the first part. Let's start, shall we? So Debayan, today we are gonna talk about linear models, the first part. Will you give us a brief about it?
So, first of all, the reason why we are splitting this video into two parts is because it's a very important concept and a very important curriculum that is frequently asked in interviews. Trust me about this. And one of the very first questions that you will be asked on, or you will be, questioned upon, is linear models and a linear family of models. So you need to understand the basic assumptions behind them, what it means to have a linear model, and what are the vocabulary around them. You need to be pretty proficient in those two. And we're gonna cover correlation, residuals, and the least squares, or the L2 norm form of the linear model. And we're gonna explore what it means, what it implies, and what can you do about it. So the very first concept we're going to revisit, if you remember from our very first video in this lecture series, is correlation, right? So what do we mean by correlation? Let's revisit that, and let's explore that in a little more in a mathematical context, right? What do you mean by correlation? Correlation describes the strength of linear association, right, between two variables x and y, right? So if you want to say that x is correlated with y or y is correlated with x, it's if we are talking about what is the strength of the association between x and y, and this correlation variable, right? This correlation variable is denoted by a symbol r, right? So r is a coefficient of regression. It's also another name, but we're going to talk about that later on in the next video. So what does r mean, right? So the r magnitude, right? It can be positive or negative, right? Positive correlation means when x increases, y also increases, or y increases, x also increases, right? Negative correlation means if y increases, if x increases, y decreases, and vice versa. So it's like a same kind of relationship or an opposite kind of relationship. That's what we mean by the symbols. But the magnitude of r, or the correlation itself, measures the strength, like just like you have a vector has a magnitude as well as a direction, right? In that same context, not exactly the same thing, but in that same analogy, you might see that the sign denotes the direction of the relationship, as to whether it's like, if I increase, you increase, I decrease, you decrease, that kind of relationship, or I increase, you decrease, or you increase, I decrease. So is it that kind of relationship? That's denoted by the symbol of plus or minus, and the magnitude r determines the strength of that relationship, or how they're correlated, or how they're associated with each other, right? So the sign would dictate the direction of the correlation, if I am allowed to say, in that aspect, right? Now the correlation value lies between -1 and 1, right? So this is like, it's either 100% on the positive side or 100% on the negative side. So that's what it means. And when you have r is equal to 0, that means there is no relationship at all. So R is 0 or close to 0 means there is very weak, or there is no effectively no relationship at all to work with, right? And like I said before, these are commutative, right? So the relationship is, so the correlation of x to y is the same as correlation of y to x, right? So it goes either way. That's, and the last point I think you must remember is the correlation value or the strength and data is sensitive, or it's affected, it's very strongly affected by outlier data points, right? So if you have a variable, if you have a case like x and y, right, and you're plotting these variables, right, you'd seem that your correlation is directed along this line, right? You'd seem that, right? But if I have a variable like this, some part over here, although this is a small cluster and you should effectively ignore it, like if you think as a human, right? But it would seem like, it would seem to the computation, right, as if the correlation will give you a value along this line, which is not exactly accurate. But you have to remember this is how correlation works, so it is very susceptible to outlier data points, and you must be aware of that. Let's talk about residuals for now. What do we mean by residuals, right? So when you're talking about a linear model, you're talking about a straight line model, just a straight line, right, in a 2D plane. Let's draw it. So you have your Cartesian plane over here, you have x and y, and then you have a model, right? Let's say you're drawing a line over here, right? This would be negatively correlated because you can see as x increases, y decreases, and vice versa. You can go along those way. So what do we mean by residuals, right? So if so, I drew this line to give you a sense of the correlation, right? In general, the data points are sort of always scattered along, right? These are what the points are in real life look like. What we mean by residuals is this line, right? Can you see the lines that I'm trying to draw over here? I'm taking the direct perpendicular, the shortest distance perpendicular to that line, to that correlation line that you saw, right? And this distances, let me mark it again. This these distances that I have marked with a blue line, like this particular distance, these are what you call the residual of that point. Let's say this is a, right? So point A to the correlation line or the regression line, let's work with correlation line for now, or the correlation line between x and y is this distance A, right, from point A. That's the residual, right? So this is what you would call the leftover, right? Leftover distance. And in real life, you would say that the data is generally comprised of your model, right, which is the line, model line. We'll talk about this later on in the next section.
Debayan, could you
Plus the
zoom in a
residuals.
bit?
Yeah, sure, sure. If you can see, right? So the data always consists of the model line, which is a straight line, plus the residuals, and that constitutes of the actual data. You can approximate in that way. And this is the difference between what's observed and what's predicted, right? Your line, this line is your model effectively, right? And if your model says that if x is equal, and this line means that if x is equal to this value, your prediction is y hat this value, right? Which may not be the right answer, but it's at least close to what you would expect, right? If it's trying to predict, right? If the actual value y is somewhere over here, right, then the residual is effectively y minus y cap. Y minus y cap. That's the actual residual, and this value is what is called the residual error. It's an error on the model, right? It's not fitting. It's an error on the model, and that's what we mean by residuals or residual model. Okay, in the previous section we talked about residuals, right? And just to remind you again what we mean by that, right? So if you have a model, right? If you have a model, let's say f, and it's saying it given an input xi. So this is your input, right? And given this input xi, it's given you a prediction yi cap, right? And your actual answer is actually yi, not y cap, yi cap, right? So the residual error
Debayan,
EI.
again, can you zoom in a bit?
Yes, yes, yes.
Yeah.
Okay. Residual error EI, right, is equal to the difference between these two, right? So the difference between these two is the residual error, right? Now, for for n points, so for many points where you have many values of x and you will get a corresponding value of y, you could try to find out the total error of the model, right? You could do something like e1. So this is e1. So e1 plus e2 plus e3 dot dot dot, so all the errors right up till en, and you take the value of it, right? You do not care about the sign, just care about the value, the total magnitude of the error, right? You could do something like this, or if you wanna nullify that position, you could do something like e1 square. Let's say you wanna give a greater emphasis on the error, and you wanna say that if you make 1 unit of error, or if you make like 2 units of error, I will penalize you 4 times. If you do 8 units of error, I will penalize you 16 times, right? That's what error means, right? So yeah, two, right? So you could do either way, right? This is something what you'd call the absolute error, right? The first one is the absolute error, and you would also call this the L1 norm. This is called the L1 norm because the power is raised to the power 1, so it's just 1, right? And this one is called the square error, and you would also call this the L2 norm because the power is raised to 2, right? So in order to optimize your model, in order to make sure that your model is very optimal and has the lowest value and gives the lowest possible residual error, right? What you'd like to do is try to minimize either of these, right? If you choose to work with the L1 norm of errors or residuals, you try to minimize that. If you want to work with L2 norm, you'd also want to minimize that. So what's the difference then, between minimizing both of them, because they mean the same thing? L2 norm penalizes or makes your model more aggressive to making less aggressive to making errors, right? Because it knows that if it makes 2 units of worth of error, it's gonna get penalized 4 times. It's squared, right? So it becomes very conservative in making errors. So like I would assume that that would mean that your model learns better, right? But in the end, it comes down to minimizing the residuals in your model so that your model can generalize better, right? This is what you would call the least squares line. We are trying to minimize the total squared sum, and we will find the model or the linear line in the Cartesian plane. If you remember from the previous slide, this line which has the minimum residual error, or the least squares line, or OLS, or ordinary least squares line. So this line that I wrote, right? So given an input xi, it gives an
Debayan,
output.
zoom, please.
Yeah, yeah. So given an input xi to a function or a model, and gives the output yi prediction, right? Um, let's what does f look like, right? What does f look like? F looks like this, right? This is the actual model. If you remember from school, right, from uni, this looks something very similar to mx plus c, your equation of a straight line, right? This is exactly what it is, but I've written it in a different way in the context that we are trying to learn, right? So this is the prediction, right? This is the slope. Sorry, this is the intercept. Sorry, that's the intercept, or the minimum value y can possibly take, even if you have no input at all, right? This is the slope, and your x is your input, right? So f is basically a linear combination of models. It's a linear combination of input variables, right? With the default variable being that's the base value for y. This is what you would call the general form of the least squares line, and this least squares line can be optimized by, you optimize this. So when we say optimize, I mean we reduce the error. We optimize residual error, which is the sum of all the predictions and the actual, the difference between the observed and the predicted value. right? It reduces the residual error sum, right? For f. And what does f look like? F look like this. This is the simplest form of the linear model, and this is the general form of the least squares line, which you're trying to optimize by reducing the residual error line.
So, guys, that was all today. We learned about starting from correlation, then we learned about residuals, then least square lines, then general form of least square lines. So, guys, Debayan explained us all the things which we need and which the industry wants, specific catering to the specific needs of the industry. Guys, if you face any problem during the journey, we have our Discord server ready down below, link down below. Do follow us. I and Debayan will always be over there to help you out. And guys, if you want to support us, please do share the content. It's a humble request. Like we are not charging anything. We are providing the content for free, but we are expecting some kind of support from the community by sharing the video as much as you can and subscribing to my channel. Guys, that's all for the day. I was your host Subhra, and with me was
Debayan.
signing off. Bye bye.